So imagine for a moment that you had to do not only with ordinary space, conceived in its three dimensions, but with a counter space or anti-space. Let me call it counter space for the moment, and I'll try to evoke a provisional idea of it as follows. Suppose I form the thought of ordinary three-dimensional rigid space. I form the first dimension, I form the second dimension, and I form the third dimension, see figure 5. In constructing these three dimensions, I have, so to speak, fulfilled the conceptual requirements of the three-dimensional space with which I'm ordinarily confronted. Now, as you know, in any such domain, you can't only advance up to a certain degree of intensity, you can subtract from it too. And as you go on subtracting, taking away, eventually you arrive at the negation of it. As you're well aware, there's not only wealth but also debt. Likewise, I can make the three dimensions not just arise in thought, I can also make them vanish. Only now I imagine the arising and vanishing to be a real process, something that really exists. Of course, it's possible to think only two dimensions instead of three, but that's not my meaning. What I mean now is that the reason why I have only two dimensions isn't that I never had a third, rather it's because I had a third and it has vanished. The two dimensions are an outcome of the coming into being and vanishing again of the third dimension. I now have a space which, although it outwardly shows only two dimensions, must be conceived inwardly as having two third dimensions, one positive and the other negative. The negative dimension springs from a source that no longer can be there in my three-dimensional space at all. I would have to draw it in not quite precisely this way, but rather I'd have to draw something flattened. Then it would correspond. I want to suggest that something was there and then vanished. Let's say that the density of an effect indicated by this dark shading arose there but then weakened again, see figure 8. Then you're left with a sphere that has a denser portion in the middle region. I ask you now, compare what's been drawn here first of all with the real system of the universe as it appears to our eyes, the cosmic sphere, with all the stars widely dispersed, and then the stars heaped up in accordance with this principle, which we usually call the Milky Way. But compare it also with any of the popular star maps. The picture we have shown, let us still take it simply as a picture, is fundamentally equivalent to what is always being shown, the passage of the sun or of the earth through the zodiac, with the north and south poles placed somewhere out there above and below. But the conception we have now built up is still insufficient for an understanding of all those things we adduced with regard to the human constitution. We have to go further. Now we have to say, let the second dimension vanish as well, so that we're left with only a single dimension with a straight line. But this is no ordinary straight line drawn within three-dimensional space. Rather, it's the line that remains after we have made the third and then also the second dimension vanish. And now let's allow the first dimension to vanish also. Then we're left with a mere point. Bear in mind that we have arrived at this point by way of the successive vanishing of three dimensions. Now let's suppose that this point were to present itself to us in reality as having existence in its own right. But if it is something that's exerting an effect, how must we imagine its efficacy? In imagining its efficacy, we can't relate its effects to any point that lies, let's say, on the x-axis. The x-axis doesn't exist, it has vanished. Nor can we relate it to anything with an x and y and a y coordinate, since they don't exist either. They too have vanished from space. Nor can we relate it in its efficacy to the third dimension of space. Rather, we have to say that when it displays its efficacy to us, we're compelled to relate that to what lies completely outside three-dimensional space. It follows from our own lines of thinking that it's impossible to relate this point to anything that could implicate it within three-dimensional space. We can relate it only to something that's outside three-dimensional space altogether. We can relate it neither to X deleted, in quotes, nor to Y deleted, in quotes, nor to Z deleted, in quotes, but only to what deletes X, Y, Z. Hence, to something that isn't within three-dimensional space at all. It's a fragment that in some strange way belongs not to my universe, but to that universe to which all the stars do not belong. If there's such a thing within a universe, then what we have is a kind of implant into the universe, something that reveals inner qualities completely different from the things surrounding it. Suppose you look into it and recognize that there's something in the human constitution that falls right out of space, is not in space at all. We began by framing this as a formal notion, but this notion becomes exceedingly real. Contemporary science hopes to master such things with comfortable ideas, but they become very, very real when we begin to enter into things more deeply. Really focus your intentionality, then contemplate the process of seeing in conjunction with the structure of the eye, EYE. You are perhaps aware, in other lectures I have often spoken about it, that the eye can't be regarded merely as a thing formed from within the body outward, but also as something that's organized into the body, inwardly from outside. You can trace the forming of it from without inward by studying the phylogenetic development of lower animals, and then considering the act of sight itself. When you study the process of sight, you have to seek to grasp inwardly how the process of sight is stimulated from without, and how the organ is also adapted to this stimulation from without. Grasp how it is that, as the process works on inward to the optic nerve and thence into the organism as a whole, it vanishes, as it were, within the larger organism. I know you can find the termination of the optic nerves, and yet this also expresses itself only approximately. If you enter into the finer structures, it's justified to say that it disappears into the organism. And if you turn then to compare the process of sight with the associated organs conscientiously with the process of secretion in the kidneys, then you'll end up having to relate the duct that leads outward for the secretion of the kidneys to what is working from without inward, where the eye transitions into the optic nerve. If you want to arrive at concepts which establish connections between these two things, so that you can comprehend the phenomena of this or that process in light of their relationship, then you'll need to avail yourself of ideas such as those previously indicated. If you think such ideas regarding the process of sight within three-dimensional space, and then seek what corresponds to that in the process of renal excretion, or vice versa, you have to think what is effected there in such a way that you exit three-dimensional space altogether. You have to go through a thought process that's exactly like what I just did in extinguishing the three dimensions. Otherwise you won't find your way. You have to proceed in the same way if you're trying to understand the curves formed in the heavens by first investigating the orbits of Venus and Mercury, and then investigating the orbits of Jupiter and Mars. I mean the apparent orbits as we observe them with our eyes, loops and all. If you use the polar coordinate system, for example, you can begin by taking the node of Venus as the pole of your coordinate system in three-dimensional space. That approach will work in the case of Venus. But you can't model the retrograde motion of Mars using the same principle. In that case, you have to start from the ideal premise that the poles of any relevant system of polar coordinates will be outside three-dimensional space. And if you try to comprehend every part of the system, you'll confront the necessity of treating the coordinates in such a way that in one instance, for example in the case of the orbit of Venus with its loop, you may start from the pole of the coordinate system and assume these polar axes here, see figure 9, but in another instance, in the case of the orbit of Jupiter or of Mars and its loop, the only way this will work is if you proceed differently. Now, you'll say to yourself, I'm going to construct polar coordinates with a different kind of origin, not one in which I need to add something in order to arrive at the polar coordinates. Instead, I'm going to take as the origin of my system of polar coordinates the sphere, that is, everything behind it, extending into a realm of indeterminacy, see figure 10. Then I get polar axes such as these, where in each case, instead of adding, I must always leave something out. The curve I then obtain in that way also has something like a center, but the center is in immeasurable spheres. It might prove necessary then for more profound research into the paths of the planets that we make use of the idea that in constructing the orbits of the inner planets, we have to imagine them as having some kind of center within ordinary space. But that when we want to think about the centers of the orbits of Jupiter, Mars, etc., it's necessary for us to leave ordinary space behind. You see, here we have to transcend space. It's entirely necessary. If you're really conscientious in your efforts to comprehend the phenomena, the concepts associated with mere three-dimensional space prove insufficient. You have to envisage the interplay of two kinds of space. One of them, with the ordinary three dimensions, you can imagine ideally as issuing radially from a central point. The second kind, which is continually annihilating the first, cannot be thought of as proceeding from a point. Rather, it has to be thought of as proceeding from the infinitely remote sphere. In the former case, the point has a surface area of 0. In the latter, it has the surface area of an infinitely great sphere. Hence, we have to distinguish between two different kinds of points. Between a point that has a surface area of 0 and turns it outward, and a point that has the surface area of an infinitely large spherical surface and turns it inward. In purely geometrical terms, it's sufficient to imagine points in the abstract. In the realm of reality, it's not sufficient. We'll never succeed by imagining points that are merely abstract. In every instance, we have to ask whether the point we're imagining has its curvature turned inward or outward. Its field of forces will vary accordingly. But you have to keep one other thing in mind. Of course, you might imagine that you had somewhere caught this point, which is really a sphere. To begin with, see figure 11, since it dwells in the infinitely remote spaces, you needn't imagine it just here, A. You can equally well imagine it a little farther out, BC. You can imagine it to be anywhere out there, so long as you leave this sphere free. For that has been left blank, so to speak. This is the inverted circle, or the inverted sphere, if you will. But now, suppose the following might be the case. Everything that lies outside this abstract circle, hence is this point that turns its curvature inward. For recall that the entirety of the space that lies outside the spherical surface is just that, a point that turns its curvature inward. Suppose this space had its limit somewhere after all. You might be able to go out far away, very far. Suppose, however, the reality were such that you couldn't go just anywhere, but somewhere there would lie a limit of an entirely different kind. What would the consequence of that be? It follows of necessity that somewhere here, P, the thing would have to appear that belongs to what lies outside. A little sphere would have to arise inside that belongs to that which lies outside. Then you'd have to realize that out there beyond a certain sphere something exists. But I can see what lies outside by looking in here, P, because it's what reappears there, what makes itself felt there again, the continuation of that which lies outside. The continuation of what is far away out there makes itself felt in here. The thing that I'm seeking when I go out into infinite distances reappears to me from out of the center. These are the kind of ideas you should develop to the degree that's needed. At any rate, they give the impression of being entirely justified in formal terms. But you'll be able to do something entirely different with them if you attempt to penetrate outer reality with such ideas. Consider, for example, that there might be a phenomenon in celestial space. For the time being, let's call it moon. This phenomenon cannot be understood by simply saying, the moon is a body. There's its center. And let's investigate this body with its center accordingly. Assume that, to put it euphemistically, this way of thinking didn't quite fit reality. I would have to say instead, if I proceed from a point in my world ever further and further outward, then I arrive at a place where I don't find any more celestial bodies, where, if I'm talking about reality, I don't find plain old empty Euclidean space either. Rather, I find something that compels me, by means of its reality, to think its continuation here, P. Then I would be obliged to conceive the space contained within this moon as a piece of the entire universe, with the exception of all that exists in the way of stars and so forth outside the moon. I would have to think, on the one hand, of everything in cosmic space in the way of stars. I would have to deal with those in a unified way. That's an initial presupposition. But I wouldn't be able to treat the inside of the moon, the spatial content of the moon, in this same way. Instead, I would have to say, there, on the one hand, I go out into the far spaces. Somewhere out there, I presume, is the sphere. Though it's only the apparent sphere to begin with, I have to conceive it somehow as being founded upon something that exerts a real effect. But no matter what I discover in the far reaches of space, what lies inside the spherical surface of the moon has nothing whatsoever to do with it. It only has to do with what begins where the stars come to an end. It's a fragment that in some strange way belongs not to my universe, but to that universe to which all the stars do not belong. If there's such a thing within a universe, then what we have is a kind of implant into the universe, something that reveals inner qualities completely different from the things surrounding it. And then we may compare the relation of such a moon to its surrounding heavens with the relation which obtains, for instance, between the secretions of the kidneys, with the organic structure that underlies them, and on the other hand the structure and function of the eyes. We'll proceed from that starting point tomorrow. It's not a personal quirk of mine that I have to try to foist upon you complicated ideas about the structure of the universe. Truth is, equipped with other notions, you won't get anywhere unless you just say to yourselves, quote, let's organize the phenomena according to these concepts, and then if we hit a limit somewhere, well, then that's it. That's as far as we can go. Close quote. If we end up with such complicated ideas, it's not because I'm addicted to complexity. It's because reality itself forms them as it leads you on to an understanding of the structure of the universe. The end of Lecture 15.